Alright, today I'm going to teach about this question. This is one of the hardest topics for IGCSE MF, and a lot of students actually ask me about this kind of question. So I decided to make a short video to explain about this one. This is one of the past year question for IGCSE. So basically, you will see something like 0606 is a code for IGCSE MF, and I think this is the paper 1-2 May June and for 2014. All right, so okay, this topic is joined between the vector and relative velocity. Okay, so do not waste time, just have a look on the questions. So okay, this question actually says that in these questions, I actually represents the vector due east, and j basically is the unit vector due north. Alright, so this is something very basic but also is quite important. So basically the question tell you, if let's say I say 1i, that means I'm going to go east 1 unit, like 3i I'm going to go east for 3 units. So for example, if I say something like 4i plus 3j, because this one is a unit vector, so that means I'm going to move like 4 unit, 1 2 3 4. So let's say this 1 2 3 4 means 4 unit to the east, and 3j's basically mean 1 2 3, like 3 unit vector to the north. Alright, this is basically what is the meaning of the first sentence. Alright, so of course negative mean opposite directions. Alright, this is something very basic and common, and if in the Cartesian plan you can do something like this. If let's say this is Cartesian plan, this one will be I, this one will be J. Alright, yeah, just for your information. Alright, so at 12 hour, I mean this one is something like 12 p.m. Okay, a ship leave a port P and travel with a speed of 26 km per hour in the directions of 5i plus 12j. So, and then the part 1, the question basically asks you to show that the velocity of the ships is 10 plus 24. So now the first question is actually how are you going to show the velocity of the ship in the vector form, because this is 10i plus 12j. If the question only asks you to find the speed, then it's very easy. Then you can find the magnitudes of velocity. However, this one, okay, so for velocity, if according to what is based on what we understand, velocity basically is something like speed with the direction. Speed with the direction. So that's why we call direction, ION. Alright, so that's why we call it velocity. So in this case, we have the speed and we have the directions. So this is what you need to do if you want to use like sort of formula. So speed is 26. Okay, and then you will need to multiple direction. Okay, if you want to multiple direction, you have to multiple the unit vector of the direction. Alright, so if you want to find the velocities in the vector form, so if you have the speed and direction, you just remember, use the speed to multiple the unit vector of the direction. Direction is 5i plus 12j, so we know the unit vector is something like 1 over 5 square plus 12 square, and then square root it, and then this is 5i plus 12j. Of course, 5 and 12, you use a calculator, it will tell you the answer at the denominator here actually is 13. So 13 and 26 you can simplify, and then you basically will get 2, because 13 and 26 you simplify, you will get 2 multiple with 5i plus 12j, then you can easily get 10i plus 24j. Then I will say shown, because you can easily get this answer. Alright, if you want to use like sort of formula for this one, but if you do not want to use this method, basically you can use another methods to find this one. Okay, let's say I know the direction at 5i and 12j. So if let's say I sketch. Oops, I'm sorry. Let me come back to this one. Okay, so yeah, I just accidentally erased that one. Okay, so for example, I know the direction is something like 5 and 12. So let's say 5 and 12, 5i plus 12j. So because this one definitely is a right angle triangle. So if I want to find the hypotenuse, 5, 12, you can do the Pythagoras easily, and you know this is 13. Okay, just assume this one basically is a ratio. So if this one is a ratio, I want to change in the speed. Now, okay, just remember the speed is always this one, the speed is the hypotenuse. So that means the speed over here is 26. Okay, just now I said that 5, 12, and 13 is a ratio. So in the actual speed is 26. So if I want to write in the vector form for the velocity, so you have to understand something like, in order to get 26 is 13 multiple 2. So that means my 5 I will multiple 2 also. My 12 I will get multiple 2 also, so which is 24. So I can easily get my velocity, which is 10I plus 24J. Yeah, you can do like this also if you want. Yeah, so then you can easily get your velocity of the ships. Alright, so this is how to convert like the direction and speed into the vectors of the velocity. Alright, so, and yeah, just something extra. If the question give you the velocity, and then the question asks you to find speed. Okay, so this is something you have to understand. So in order to get the speed, you just need to understand speed basically means the magnitudes. It basically means the magnitudes of the velocity. So that means in order to get the speed, you just do something like square root of 10 square plus 24 square. And then of course you will get 26. Alright, this is how to, like, if the question give you the velocity in the vector form and you want to get speed, so you just do the Pythagoras lah. So, or I would say it's the magnitude of the velocity. Okay, because this kind of knowledge is quite important in this topic. So yeah, I just want to say a little bit just to make sure you can understand. Alright, so okay, let me just erase this one, then we can go to the second part. Alright. So, okay, for the second part, the question says write down the position vector of the ship relative to the P at 16 hours. So you need to write out the position vector. So over here you have to understand what is the meaning for position vector. So in order to have understand position vector, you must understand the origin. Origin is O. But then in this case, I would assume the origin itself is a port P. So I would assume my origin O here is P. This one is P. So if I says my position vector is something like position vector, let's say I say position vector is 18I plus 24J, that means I will calculate 18 units from origin and then like 24 units over here from the origin also. So this is my position vector, like 18I plus 24J. So must always relative back to the origin. So in this case, I will assume the origin is P. So in all the question, you always see the question actually write something like relative to P, means they calculate like from the port P. Alright, so yeah, this is something to do with position vector. And then what you will need to understand about position vector is okay, position vector in this kind of question actually is kind of similar with distance. So not to say similar with distance, but it's something to do with a distance. Because position vector mean what is the position of the particle. So that's mean relative to the origin. So it's kind of something like the distance from the origin. I will explain this one further in the question later. Alright, so in this case, the question asks you to write down the position vector of the ship relative to the P at 14 hours. So that means if you have the velocity, you want to get the position vector. So just assume position vector is a distance, velocity is a speed. We always know speed equals to distance over time. So in order to get the distance, so I know this is like speed multiple with time. Just assume speed is velocity. So in the second part here, in order to get knows after 4 hours, because the ship actually moving at 12 hours, so 16 is actually after 4 hours. So in this case, I know my t basically will equals to 4. So in order to find my position vector, it's very easy. I just use the 4 to multiply my 4 is a time multiple my speed, which is my velocity, 10 plus 24j. So my position vector is like 40i plus 96j. Okay. This is some sort of formula, like a distance equals to like time multiple with speed. Okay. However, if you want to use the graph, you want to understand in other way, maybe I can try to use other way to make you understand. So let's say I have a I and j diagram, which they call it Cartesian plan. So if the ship travel 10i plus 24j km per hour, mean every hour the ship going to travel like 10 plus 24, correct or not? If you understand the velocity like this. So let's say this is something like okay, let's say this is something like 1024. Let's say this is 1024. This is every 1 hour. So 4 hours, that's mean you're going to move 4 times. 10, 24, 10, 24, and 10 and 24. You just assume it's 24 because I couldn't touch this one. So this is 10, 10, 10. This is 24, 24, 24. So that means this is every 1 hour. So after 4 hours, total here will be 40. Because 10 plus 10 plus 10 plus 10. You have 410, which is 40. And this one will be 24 plus 24 plus 24 4 times, which is 96. So the position vector of the ship will be 40i plus 96j, because this one will be the position like after 4 hours. So if the question asks me about after 5 hours, so basically I will multiply 5 into the velocity, because the velocity over here means like every hour the ship going to travel like 10i plus 24j. Okay, so you have to understand, if let's say after 10 hours, so I know the position vector of the ship is 10 hour will be 100i plus 240j. After 10 hours, just use a 10 to multiply this one. So if you understand about this concept, then you can easily get the answer for the part 3. Because the part 3 asks you to find the position vector of the ship relative to the p, mean relative to the origin here, t hour after 16 hour. 1600 hour. So I know this is the position vector at the 16 hour. So that means, so what is the position vector after 16 hour? So in order to understand this, it's very easy. So just assume at 16 hour, my position vector of the ships, which is 40i plus 96j. But after means what? So I want to know about next hour. Next hour means 1700 or 1800 or 1900. So what I will do is I will plus. So I know in order to find each hour, like where's the position vector, we know we always can do something like speed multiple with time. Correct or not? So my velocity, which is 10i plus 24j. So time, which is t. So this is how I do. So you can imagine. So if I say in 18 hours, so I just substitute my t equals to 2. So I will get 20i plus 48j. Then I and I will plus together. J and j I will plus together. Then it's the same concept. You straight away is like do like 6 hours from the 1200 hour. Okay, so yeah, this is the basic idea. This one is because at the 1600 hour mean like 4 p.m. the ship actually at this position. So but the ship will continue travel in this velocity, because velocity basically is direction plus the speed. So it will travel at this one, and time is it's a variable. It depends what is your time. So and then I will simplify this one, and I will join together. This one basically called 10ti. So I will say this is 40 plus 10t, and then bracket I. I factorize out the I. Then I do the same thing for the z, so which is 96 plus 24 t z. So this one will be my position vector relative to the t hour after 16 hour. Alright, so yeah, you remember always you have to write down the origins. I mean the old position vector, or you can call it original position vector. Okay, you always need to do this one plus the new position vector. Okay, the new position vector, of course, in order to get a position vector, you just remember always use the velocity and multiple with time. Okay, so if you remember this one, then you can easily solve this kind of question. Alright, then okay, let me move on to the next part. Okay, but this one I will leave it here because I know I'm going to use it later. Okay, it's 16 hours. The speedboat will leave a lighthouse which has the position vector 120i plus. Okay, so this is the this is I would say this is a position vector of lighthouse. So it's of lighthouse, which is 120i plus 81j. Alright, so okay, relative to p. So this one means from the p itself is like, if this is p, so it will be about like 120 here and 81 here. So this is the position vector of the lighthouse. Alright, so yeah, just for you to understand. Alright, so the question says, okay, so the speedboat is going to intercept the ships. Alright, so the speedboat have the velocity. So yeah, the question also gives you the velocity of the speedboat. Alright, so it's quite easy. So it's like negative 22i plus 30j. And then the question asks you to find the position vector relative to p, the speedboat of the speedboat, t's hours after 1600 hour. Alright, so it's simple. So in order to get a position vector, so we know we have to write down what is the original position vector first. So at the lighthouse itself, it will be 120i plus 81j. This one will be the original position vector plus the new position vector. So in order to get a new position vector, we know we always use the velocity multiple with time. So the velocity will be negative 22i plus 30j. But this one is a velocity, so in order to make it become position vector, remember multiple with time. Okay, so if time is 5 hours, just write t is 5. But in this case, of course, the question actually asks you live in terms of t. So this is how they bring out the information. They will say, yeah, the speedboat t hour after 1600 hour. Alright, so I will do the same thing. I will join I and I together. So this is 120 minus, not plus. So it's minus 22t I plus 81j. So plus 30t j. Alright, so this one will be the position vector for speedboat, and this one will be the position vector for ship. Alright, so just don't confuse. This one is for ship and this one is for speedboat. Alright, okay, so what is the meaning of this one? So okay, if you get this kind of position vector, is very useful because whenever the time is changed, so you just insert into the t. But then remember, this position vector is start calculating from the 1600, means start calculating from 4 p.m. and you will realize both is 4 p.m. So the good thing is, because both is the both position vector is formed using the 4 p.m. That means if I add the 1 hour for both, the t will be the same. If I add 5 hours here, means it will be 9 p.m. If I add 10 hours here, it will be like 2 a.m. Alright, so okay, so you just make sure you understand it start calculate for 4 p.m. and both will have the same t value. Alright, so and then we go to the last part. The last part, the question asks you to find the time which the speedboat will intercept with the ship and the position vector. So basically you have to find the time, both the speedboat and the time will intercept, and the position vector of the point of intercept. So like where they're going to intercept. I mean what position they're going to intercept. So okay, so first, in order to solve the intercept kind of question, so what you need to do over here is, first thing is you have to understand about intercept first. Okay, intercept case, it must be at the same position vector, then only we call intercept, correct or not? So means if the intercept at 100 I plus 200 J, mean the ship going to arrive at this place, and the speedboat also need to arrive at this place, then only both of them can intercept. So that means both of them must have the same position vector. Alright, this is for intercept. So first is they must have the same position vector. Second, when they intercept, they must at the same time. So that means if I say the speedboat going to intercept with the ship at the 9 p.m., that means when they meet, the speedboat will at the 9 p.m. and the ship itself will at the 9 p.m. also. So that means they will have the same t value. So there must be same time and same position vector. Alright, this is something very important for intercept. Alright, so if you understand about this one, so I have the position vectors of speedboat and I have the position vector of the ship. So because they can have the same position vector, so I can say this position vector is equal to this position vector, because at the end they will need to be the same and the same t value. That's why I can substitute. I don't need to do something like t1, t2, because the t value is the same. So what I will do over here is I will write it down is something like 120 minus 22t I plus 81 plus 30t j equals to 40 plus 10t I plus 96 plus 24t j. I will make them equal. Alright, then what I will do is, in order to get the t value, I will comparing the I. So when I comparing the I means what? Means I will only compare the I with the I, and then I will compare the J with the J later. Okay, so I do the I part first. So I will say 120 minus 22t equals to 40 plus 10t. Then I can easily get my t value. So this one will be my 32t will equals to 80. 120 minus 40. So then I can easily get my t value by using the calculator. So my t basically will be wait for a while, I use my calculator. So it will be 80 divided by 32, so it's like 2.5. Alright, it's in hour. Alright, this is 2.5 hour. So if the question asks like what time they are both the ship and the speedboat and the ship going to meet, because both of them is like from 4 p.m. right? So what I will do is 4 p.m. I will plus 2.5 hour. So they're going to meet at, of course 4 p.m. they write 1600 lah. So that means the time will be 1600 plus 2 hour 30 minutes. Alright, I will do something like this. So it will be 18. I'll be 1830. Alright, this is how they're going to meet. This is 2.5 hour. Of course here I can not do 2.5. I just do like 2 hour and 30 minutes, because this one this is international time. International time must be in hour and minutes. Alright, I can not write 18.5. Alright, because this is time. Alright, this is very easy. Then the question want to know about the position vector. So since I know the t equals to 2.5 and I got the time also, so I just substitute 2.5 into my t, and then I can easily get my position vector. So in order to do that, so in this case I don't need to compare j already, because I only have one unknown t. So I comparing the I already got the answer for t, so I'm not going to compare the j again. Alright, so okay, since you know the time already, so I'm going to erase the time. And then maybe I will do the position vector part. So this is, yeah, so for position vector part, because both of them have the same position vector, you just choose one of it. Maybe I choose this one to do. Mean I just substitute t equals to 2.5 in either one. I can substitute into this one or this one. Both of them will get the same answer. So this is 2.5. 2.5 will get 25. 25 plus 40 will be 65i plus 2.5 over here. Just use the calculator, like 96 plus 24 times 2.5. So you get 156j. So this is the position vector. Both the shape and speed are going to meet. Alright. So yeah, that's all. I think this question is about 12 to 14 mark. I can't remember the total mark of it. But then yeah, this kind of questions is, yeah, you need to understand what is the meaning of position vector. When you have the velocity, how are you going to find the position vector? So if the question gives you the speed and the direction, how are you going to find the velocity? If the question gives you velocity, how are you going to find the speed? And yeah, and when they intercept, how are you going to find their position vector and time? So yeah, you will need to understand a lot of things for this kind of question. Yeah, I think in the future I will post more example about this kind of question. Anyways, I hope this video actually can help you understand quite a lot of things about this topic. Yeah, thanks for watching.